Okay. So we have 9.3, the law of cosines today. On Tuesday, we did the law of sines, which dealt with cases 1 and 2. And now we're going to do the law of cosines, which deals with cases 3 and 4. Two sides and an angle are known, side, angle, side. And case 4, three sides are known, side, side, side. Okay. Down here is the formula for the law of cosines. So for a triangle with sides A, B, and C and opposite angles A, B, C, respectively, we get that C squared is equal to A squared plus B squared minus 2AB cosine C. B squared is equal to A squared plus C squared minus 2AC cosine B. And A squared is equal to B squared plus C squared minus 2BC cosine A. Okay. Now, what we want to do is rearrange all these equations to solve for angles A, B, and C. Well, I went ahead and saved us some time and did it already. So you see, let's just look at angle A. So when you start with A squared equals B squared plus C squared minus 2BC cosine A, well, the first thing you do is you move B squared and C squared over to the left, which would get us here. And then you would be left with negative 2BC on the right side, and you would divide by negative 2BC, which is there and there. Okay. And then after you do that, you would end up with a statement that says negative, well, first off, you would get A squared minus B squared minus C squared over negative 2BC, but you would take this negative, move it to the top, and then our final result would be negative A squared plus B squared plus C squared over 2BC equal to the cosine of A. And then to get angle A all by itself, you would apply the what?
Inverse cosine.
The inverse. Good. You would apply the inverse, and you'd get the inverse of all of that equal to angle A. And guess what? The process is the same for the next two equations. So if you want angle B, there's the formula, inverse cosine of negative B squared plus A squared plus C squared over 2AC. And then for angle C, it'd be inverse cosine of negative C squared plus A squared plus B squared over 2AB. Okay, those are the equations for the law of cosine. The first three help you solve for the sides, and these last three help you solve for the angles. So this is what we'll be using today. Okay, cool. So definitely need a calculator. All right. Here we go. Use the law of cosines to solve a side angle side triangle. Here we are given side A is 2, B is 3, C is 60 degrees. Okay. Let's draw my triangle. Boom, boom. All right. So side A, we don't know angle A. We don't know angle B. We know angle C is 60. And then side A is 2, side B is 3, and we're going to look for side C. Okay. So we have enough information to find, what is it? Side C. And I think if we find side C, that will open up everything to help us solve for angles A and B. Okay. So that's what we're going to do first. Side B. And we're using, that's not B, sorry, side C. And we're using C squared equals A squared plus B squared minus 2AB cosine C. Okay. So just plug in A and B and the angle C, and we're going to compute this. So A squared Here, we'll do it step by step, right? 2 squared plus 3 squared minus 2 times 3 times the cosine of 60. And then 4 plus 9 minus, what's that? 4, that's 12 cosine 60. And then clean it up. 13 minus 12 cosine 60. And let's see what we get.
Oh.
We get that. Well, here you're going to get 7. Okay, but remember, it's not C, it is C squared. So now to solve for C, you'll just square root both sides, and you'll get C equals the square root of 7. We normally get plus or minus, but can we use the minus?
Not here.
Not here, because we're dealing with length, right?
Yes, sir.
Okay, and now the square root of 7 to 2 decimal places. .65. There's side C. Okay, perfect. So now we know sides A, B, and C, and we know angle C, and this is enough information to solve for angle A or angle B. It does not matter. So let's say we want to find angle A. If we're going to go for angle A, we're going to get that A is equal to the inverse cosine of negative A squared plus B squared plus C squared over 2BC. And now plug in A, B, and C. Here we go. Yeah. All right. Better. Okay. Okay. So plug in everything we know, and we get negative 2 squared plus B squared plus C squared over 2 times B times C. Okay. And of course, if you wanted to make it look nicer, you'd have negative 4 plus 9, and that should give us 7 over, I'm just going to leave that just like that. And let's see what we get. So the inverse cosine of negative 4.
I'm assuming the 7 is from the 2.65, right?
Yeah, so 2.65 squared is 7, because that's what we did down here, right?
Yeah. I just
There we go. We good. And then over 2 times 3 times 2.65. Oops, I did divide. No, fixed. Okay, and we get A is equal to 40.99 degrees. Okay, cool.
And then that negative a squared, that just came from the equation above, right?
Exactly. And now if we know angle A, we know angle C, what is the value of angle B?
(180 minus 40.99 minus 60).
There we go. Let me just move this.
We're like 99.91.
Are you using a calculator?
Nope.
Then don't guess.
Oops, 79.01.
There you go.
Don't trust me.
That's why I use a calculator, right? Okay. So there you go. That is how you use the law of cosines. So just know the formula and you'll be okay. So any questions on that?
No.
No. All right. Let's keep going. All right. So here again, use the law of cosines, and we're given a triangle that is B is 1, C is 3, and A is 80. So here's 80 degrees. We don't know B. We don't know C. We don't know side A, but we know side B is 1 and side C is 3. Okay, cool. Well, here, I believe we have enough information to find side A. So let's do that. And that's A squared equals B squared plus C squared minus 2BC cosine A. And we'll get A squared equals B squared, which is just 1, plus C squared, which will be 9, minus 2 times B times C times the cosine of A. Okay. And we get 10 minus 6 cosine 80 degrees. Let's type that in.
So whenever we do these, we're always going to solve for the sides first.
It depends on the information given. I think on the next examples, we're given sides and maybe no angles. Because remember, we can use law of cosines to solve a side. But yes, here there's not enough information to solve for angles B or C, because in order to solve for B or C, we need to find side A. So based on the information, you'll know what to solve for, because you're gonna need to know what pieces that you need. All right, A squared is 8.96, and then square root both sides. And the square root of my answer is 2.99. Which means, since we know side A, we now can solve for angle B or angle C, which again is what we'll do. So angle B is going to be given by B equals the inverse cosine of negative B squared plus A squared plus C squared over 2AC. Okay. Plug in our components and we get the inverse cosine, and B is going to be, so it's going to be -1 plus a 2.99 squared, which is going to be our 8.96. We'll just put it at that. Plus c squared, which is 9, all over 2 times a times c. And let's calculate. -1 plus 9 over 2 times 2.99 times 3. And I will get that angle B is, oops, we're calculating all that, so I don't need that. Angle B is 19.22 degrees. Okay. Which means angle C is going to be 180 minus 80 minus 19.22. And we get 80.78 degrees. There we go. Everybody good with that?
Yep.
Okay, cool. Let me fix that one. There we go. Bam. All right, cool. Okay. Next is use the law of cosines to solve a side triangle. So here we are given nothing but sides. So let's try that out. Don't know angle A, don't know angle B, don't know angle C, but we definitely know the sides. 4, 3, 6. Okay. Which means we have enough information to help us solve for any of these angles. So let's just start by finding angle A. Actually, just do that. It's going to be equal to the inverse cosine of -a squared plus b squared plus c squared over 2 times AC. That's AC, BC. Ha. BC. Got it. Okay. And now angle A is going to be the inverse cosine of -4 squared. Actually, we can just plug the numbers in, right? 4 squared is 16. So -16 plus 9 plus 36 over 2 times B, which is 3 times C times 6. And let's see what we get. Does anybody need me to show how to type this in on the calculator? All right then. 36.34 degrees. there's angle A. Okay. Which means let's go ahead and find angle B. Why not? Angle B gives me the inverse cosine of negative B squared.
We're
plus-
in degrees, right?
Yeah, make sure you're in degrees.
I have a question.
What's up?
So if we found the first one, couldn't we just subtract that from 180 and get the other one from that in a way?
That should be true, but let's see. But how do you know if it would be long to angle B or C?
True.
So it's a good thought, but yeah, how do we know which one would be B or C? So
Wait,
yeah.
wait, you're saying subtract 180 from 36,
Mm-hmm.
and
You kind of like see which one's the bigger one and which one's the bigger number will correspond to the bigger side. You can kind of just kind of cheat your way like that, I guess.
Maybe.
wait, no, explain that to me. Okay, 180 minus 36.34, it gives you.
It gives you the side, so all you'd have left is the other one, but you'd have to figure out which one it is.
No, because no, it won't work.
You subtracted. Wait.
Yeah. Because if you did 180 minus 36.34, you get 143.66.
How would you know what goes where? It could be like one.
Exactly.
and it
Yeah,
could
so
be
it's,
like 49.
yeah, so it definitely won't work out that way.
Okay.
Yeah. Good thought though. All right, so here negative B squared, so negative 9 plus 16 plus 36 over 2 times 4 times 6. All right. So negative 9 plus 16 plus 36 over 2 times 4 times 6. And we get that angle B is 26.38 degrees. Okay. And now we can find angle C by doing 180 minus all of these. We get angle C is 117.28 degrees. There we go. Nice. Okay. So that's how we do those sides. All good?
Yeah, I was gonna ask a super simple probably question.
What?
That has like nothing to do with the work at all. Well, it's
Oh.
like, okay, when you're like subtracting, like how do you even subtract decimals? Do you just like do it the regular way?
Yeah, you do the regular way. You can move the decimal out and then bring it back in.
Nah, see, I got like 0.16. All right, but that's whatever.
Yeah. Think of it like money
Parentheses.
math. Do it like money math.
I don't know.
Like-
much.
You don't know
Oh.
money math. All
Yeah.
right.
I just get the money is all.
You just get the money. How do you do decimals? Use a calculator. All right, here, don't know A, don't know B, don't know C, and we know sides, 12, 13, and 5. All right, let's do it again. Angle A inverse cosine of negative a squared plus b squared plus c squared over 2bc. Plug in what we know. And we'll have negative a squared. What's that? Negative 144 plus 169 plus 25 over 2 times b times c. All right, let's see what we get. We get angle A is 67.38 degrees. All right, cool. Anybody notice anything special about this triangle?
It's a 13, 12, 5.
Which means it should have what type of angle?
I honestly like just kind of said that because those were the numbers on it.
It's a special case triangle, right?
Yeah.
Define special.
Yeah.
Special 3, 3, 4, 5,
Okay, and see that's kind of
5, 12, 13.
But what do those mean to like what we're doing now?
Oh, they're related. That
Huh.
means we would have what type of triangle?
A 13, 12, 5 triangle.
Right triangle?
A special right triangle.
So that makes it 110% right because it's a 13, 12, 5.
Exactly.
And it also works the same with 3, 4, and 5.
Exactly.
Oh, lit. How many of these kinds of triangles are there? Infinite?
As many as you want to make up, but
True.
I mean, because we were making them up when we were using the unit circle, right? We would have like 1 square root of 2 and 3, right?
Hmm.
So things like that.
Well, yeah, true.
Yeah. All right, what's this? Negative 169 plus.
Oh, but I guess the point you're trying to make is that it's a lot easier to remember the fact that a 3, 4, 5 triangle is a special case right triangle.
Exactly, which will make our work easier because it's telling us that, hey, we're going to have an angle that is what?
90 degrees.
90 degrees.
So just do 67 point. Oh, but you don't know which one is the 90 degree.
That is correct.
It's estimated on the size of
Okay,
the
well, actually, okay, because of like where the numbers are in regards to B or C or A, like angle of A, B, or C, will that tell you, or like 13, 12, and 5, will that tell you where the 90 degree is?
It should. It shouldn't. Yeah.
Oh, no.
Here. Well, B is 13, right? So this
Yeah.
means that this is 90 degrees.
So the other one should be 22.62.
If you did your math right, yeah.
So that would mean then the 90 would have to correspond to side, would be angle B then, right?
So
Yeah.
in the 13, 12, 5 triangle, if C is pointing to 5 and if A is pointing to 12 and B is pointing to 13, that means that B is always 90?
I would
I
assume
mean, I
so.
guess we're doing
right?
this like whole problem, and that's kind of like, you know.
The way I see it is that you got 67, 22, and 90.
So does
90
the
is the
bigger
biggest one, so it has to go to the bigger side, right?
so the bigger side gets the bigger angle, right?
Mm,
Has that been true in all these cases?
I suppose it has.
And then the smallest angle has to correspond to the smallest side, right?
Yep. It's true here.
B was 22. Yep.
It's
So-
true here.
Well, wait, what was A on the one that we just did? 8
67.
of 4, 36.
So this one
No.
we could cheat because we only in the right angle one.
Exactly.
Well, there's a wait. Sorry, I don't know.
Yeah.
Yeah.
Yeah, that's something. But I mean, it would have to be a special case triangle, which means that the triangle I drew would actually not represent the triangle that we're working on. Because can any of these angles that I drew actually represent a right triangle?
I mean, this is saying
No.
No,
Oh well, it'd have to look different. Yeah. But
exactly.
we're using our imaginations here. So if there's one thing you've taught us to do,
So there'd be your A, B, and C.
I'll give credit to Roy. He's the one that kind of stumbled upon this.
Sorry, what happened?
About your thoughts of just subtracting 180 from it, but
It works here, bro, because we got the 90-degree angle.
it would
Uh-oh.
work in this case because it's a special triangle. So since it's a 5, 12, 13, it has to be a right triangle.
and say if it was a 3, 4, 5, it would also have to be a right.
And then our assumptions right now, and they haven't been proven wrong yet, is that the bigger angle belongs to the bigger side.
Okay, well, you're the one that's probably done a whole bunch of triangles in your life. Is
So
it
I'll
just
call it our assumption because I'm not going to say it's proven.
Ah,
But if it works, it works.
is there a proof that we can do on this?
Let's make one up if there's not one.
Tight. After meet me after class.
Yeah. All right. Okay, so that is just computing triangles using the law of cosines. Everybody good with that?
Yes, sir.
Yep.
All right. Word problems. Yeehaw.
We're having so much fun.
Woo. All right. Gets even better, right? All right. A motorized sailboat leaves Naples, Florida, bound for Key West, 150 miles away, maintaining a constant speed of 15 miles per hour, but encountering heavy crosswinds and strong currents. The crew finds after 4 hours that the sailboat is off course by 20 degrees. How far is the sailboat from Key West at this time? All right. Let's see. Let me zoom out. Let's draw our diagram. And let's say that up here is Naples, Florida, right?
You wouldn't have Naples be angle A?
Oh, I wouldn't put labels on anything just yet,
Oh,
right?
Got
And this boat, let's see, is going to Key West 150 miles away, wherever Naples, Florida is. Is it on the right side or left side of Florida? I would assume it's on the right side if you're going to the Keys, right?
And wouldn't the left side just be like back to the United States?
Whichever. Oh,
Like
well,
middle
we
of
don't
it?
know our geography here. It's fine. Let's just say that we're going this way. Here's the way our sailboat went, right? Okay. So, and we're traveling to Key West, right?
Okay.
So let's say that Key West is down here somewhere. That was our original route. And now we are off course by how many degrees?
20.
20. So here's 20. I wonder if I could draw a better triangle. Hang on. Let's see.
That
It's
was
beautiful.
Yeah, that was a great one.
That was great, right?
Hey, just to be honest, out of all the lines this semester, that was
Oh, no. See, even that one's even worse. All right. There we go. Back to that one. All right. And down here is our boat. Okay, so we are off course by 20 degrees. So this means that this angle will be 20 degrees. Okay, but the first question says, how far are we from Key West at this time? So how fast were we going?
150 miles per hour or 15 miles? I don't know. 15 or 150 miles.
We were going 15 miles per hour. And how long were we traveling?
4 hours.
So how far have we gone?
60.
60 miles. Good. We've gone 60 miles so far. So that answers A. B, through what angle should the sailboat turn to correct its course? So here we have to think about it a bit. The sailboat is still traveling this way, right?
It's
Mhm.
how's the answer A? Isn't that it's saying for the distance between the boat and Key West?
No, that's 150. Oh no,
Yeah.
Naples
From Naples, Florida
to
to
West.
Key West is 150 miles, right?
Yeah.
Oh, I still have it on ink to shape. Ah, this is 150 miles. So now we've traveled this, we traveled 60 miles within the 4 hours, and it says, how far are we from Key West at this time? So it's going to be 60 miles. We've traveled 60 miles, right? So that means, actually, so yeah, we haven't found the actual answer yet. We need to find this,
That
right?
would be that. Yeah, that's
There you go. Sorry, my bad. What do you want to label it? A, B, C, X?
We'll do X.
X. Okay, now we'll answer A. All right. So for A, we need to find side X. Okay. So we know two sides and an angle. So we know side, angle, side. So this means that if we manipulated our formula in terms of X, it's going to be X squared equals our two sides squared, 60 squared plus 150 squared minus 2 times 60 times 150 times the cosine of 20 degrees. All right. We good with that?
Yes, sir.
Yeah. And I'm just going to type all that in the calculator. 60 squared plus 150 squared minus 2 times 60 times 150 times the cosine of 20 degrees. And we get 9,185.53. And then we square root both sides. And I get X is 95.84 miles. There we go. There's the right answer for A. So we are 95.84 miles away from Key West. Okay, now on to B. So the boat is still going in the same direction, and we have to figure out what angle to turn at to get back on track. So we need to know what angle to turn at to get back on track. And in order to find this theta,
Well,
we're going to have
couldn't
to
we just
find
like the inside angle.
exactly. So in order to find this one, we're going to have to know what this angle is.
Then subtract it from 180.
Let's label it. Oh God, we started with X, huh? So let's label this
Big X.
big X. No, because that's not across from it, right?
Oh, true. We'll label it small 150 or big one.
Big 150. How about we just say B?
Y or Z or something.
Yeah.
Let's just say, yeah, fine. We'll call it Y.
Yeah, there we go.
We'll call it y. Okay, so if we find angle y, then we can find our theta that we have to turn at. So that's going to be b. Angle y. All right. Now putting this in terms, you're going to have the inverse cosine of, and it's going to be negative 150 squared plus 60 squared plus 9.854 squared over 2 times 60 times 95.84. There we go. Let's see what angle y is. Negative 150 squared plus 60 squared plus 95.84 squared over 2 times 60 times 95.84. And we get that angle y is 147.64 degrees. But we're not looking for angle y, we're looking for theta. So in order to find that theta, we just subtract what?
180 from it, or
180
180 from the.
Yep. And we get 180 minus 147.64, and we get 32.36 degrees. So that's the angle we have to turn at. 32.36 degrees. All right. That'll get us back on course. Okay. And now C. How much time has been added to the trip because of this? Assume that our speed remains at 15 miles per hour. Okay, so we want to know how much time has been added to this.
I'm getting like a super messed up number.
So then you're just going to take that 95 and divide it by 15.
95 divided by 15, what would that do for us?
Okay, so 15 miles per hour, right?
Yeah, that's not going to do it because since we've traveled, so look, so we've traveled 60 miles so far, right? And now we have 95.84 miles to go. So this 60 plus 95.84 means we are traveling 155.84 miles when we should initially have been traveling how many miles?
Wait, sir.
What's up?
So for angle Y, you got 147.64 degrees?
Yeah.
Shouldn't it be, oh no, it's between 90 and 180? Okay, because I got like a super messed up weird number for that. I mean, well, I don't think it's messed up, but I mean.
What'd you get?
I got like, I mean, I got 12.36.
Are you in radians?
I thought I changed it to degrees. Yeah, I'm in degrees.
Check your signs. Make sure you didn't put this negative inside the parentheses.
Oh, I did. Oh, wait, no, I put it outside of the parentheses. But then okay, so for me, what I had done was, because I set it up like a regular like triangle, right?
Mm-hmm.
And so you're looking for, you would be looking, oh, wait. No, I see what I did wrong. I was, okay, no, never mind. Go ahead.
Okay, back to what we were doing. So we've traveled 60 and now we have an additional 95.84 miles to go. when initially we should have only been traveling 150 miles. So we have added an extra 5.84 miles to our journey. And now this question says, how much time has been added?
So 15 times 5.84.
No,
It still
we don't
says
want to do that.
a constant of 15 miles per hour, right?
So remember that we can use the distance formula to solve for time.
Ah,
And if you rewrote this as d over r equal to time, well, how much more miles do we have to travel?
5.8.
5.84.
5.84. How fast are we going?
15 miles per hour.
15 miles per hour.
Your miles
And what is 5.84 over 15?
per, I don't know.
0.39 hours. But if you want to put that in terms of minutes, you'll multiply it by
60.
60. And how many more minutes do we have to travel to Key West?
$23.4.
23.4 minutes. So we added an additional 23.4 minutes to our journey. On a boat.
So the takeaway from this is the idiot who decided to sail on a windy day made us do all this math.
Exactly.
Oh, and then they have to do all this math to find their way back.
That, yeah, maybe it was at night. That's
Oh,
even worse, right?
oh, y'all should watch it Drift. It's a good movie.
This lesson brought to you by that movie. How far is it by car? 4 hours and 37 minutes. All right, not bad. So Naples, Florida is actually on the left side of Florida. So it's a straight shot down, just like I drew. Oh my goodness. All right. All right. Next one. Distance to the green. A golfer hits an errant tee shot that lands in the rough. A marker in the center of the fairway is 150 yards from the center of the green. While standing on the marker and facing the green, the golfer turns 110 degrees towards his ball. He then paces off 35 yards to his ball. How far is the ball from the center of the green? All right. Let's see. Here is our diagram. So boom. Here's the golfer standing on the marker, and the marker is 150 yards from the center of the green. There's the center of the green. All right. And now, standing on this marker, the golfer turns 110 degrees towards his ball and paces off 35 yards to go get it. Here's the ball. Yeah. All right. So this is 35 yards. This is 150 yards. And we want to know how far is the ball from the center of the green. Let's just label this one now. Why not B? So this will be A. we know that the golfer turned 110 degrees. So this will be 110 degrees. And here's C. Okay. And all we have to do is find B. So let's do that. Side B. B squared is equal to A squared plus C squared. Either way, you have it backwards, but okay. A squared plus C squared minus 2 times A times C times the cosine of angle B, 110 degrees. Boom. And type all this in. Let's see. 150 squared plus 35 squared minus 2 times 150 times 35 times the cosine of 110. And I get 27,316.21. Square root both sides, and we get that the golf ball is 165.28 yards from the green. Oh man, he hit it way off, right?
Yeah, 110 degrees off.
110 degrees off. Oh boy.
Don't judge him. He's a Jerry.
Can't have the Meeseeks can't help him.
Yes.
All right, everybody good with that?
Yes, sir.
Yeah, which the previous problem was this he passed.
That was like freaking 10 things. I mean, we should have just found all of it anyway. We should still just find all of this one too.
Yeah, you do that. Hey, that was the last one. Look at that.
let's do it.
Oh, thank God.
Wow. All right. So yeah, so there we go. That is Law of Cosines, which is our last lecture, which sets you up for exam 3. So if you have any homework or review questions, we have the time left over for it.
So-
I have